Three cells of EMF, E1, E2, and E3 are connected into a circuit as shown. Now you can see the circuit. Can you tell me that is it? Do you think it's a case of Kirchhoff?
Yes, like the current entering to the junction will be equal to out.
Because junctions are there, multiple power sources are there. Now, Kirchhoff's first law states an equation relating I1, I2, and I3.
I3 will be equal to I1 plus I2. Because wasn't the I3 the current leaving the battery?
You're right. I was making a mistake, and you're right that I1, I2 are coming, are the current input, and the I3 is the current output. E1, E3, R1, R3, R4, I1, and I3 in loop. W, X, Y, Z, W. So we are taking the bigger loop. So now try to make an equation. You can see the polarity. Should I add the EMFs or subtract them? This part is neglected in this loop. So E1 and E2, E1 and E3 should be added or subtracted?
The EMFs will be added.
Because they are in plus minus order. Now, every current goes with the corresponding resistance. So I3 will go with R4. And I1 goes with R1. That looks fine. Now it says the loop YZWY.
Like the triangle which is being formed.
YZWY. 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 So it means we have to, we can say that this part is neglected. Now we have a plus here and we have a minus here. Now, should I add E1 and E2? They are in plus plus.
Then they'll be subtracted.
And now we have to suppose that E1 is bigger or E2 is bigger. We have to suppose one of them. So I have made E1 minus E2. So what should I take next?
So we'll take this I2, R2.
I2 R2, but for I should take I1 R1 because it's coming out of from here, na, this current. I1 R1.
Plus the I2 R2.
That's an important question. Should I take plus or should I take minus? You have to see the direction of current I1 and I2. If you see the direction of I1, I2, they are opposite.
So then there will be minus. They're opposite.
I2 R2 will be minus.
This is charge per unit time, the current.
Good. It is the rate of flow of charge carriers. A metal wire has length L and cross-sectional area A. So what formula should I suggest? B part 1.
The I is equal to NAV.
NAVE. Now this is the derivation. Derivations are case of memory. Now, how should I derive this formula?
We'll use the formula for charge. Like of one electron.
The ratio formula. You can see the top values that I is the current, N is the number of free electrons per unit volume, V is the average velocity, E is the charge of an electron. And this is the length of the conductor L. So do you remember how we used to calculate charge? Actually, charge is the how we calculate charge. Q is equal to NE. E is the charge of an electron, and N is the number of electrons. It's a many people forget this formula, but it's a very technical formula that See this first step. N is the total number of electrons. Volume, area into height. What is L upon T? Length upon, Hmm?
Volume,
No. Length, meter per second. L is meter, na?
velocity.
Yes. Ideally, you should always copy the work which I'm doing, so it will be a good revision.
Hey, this one is a bit like difficult. I tend to forget this one.
But I think you can remember it. Have you copied it?
Yes, I've copied it. Like in all of the papers I've done so far, this hasn't appeared.
It's a very rare topic.
I've copied it.
Good. A metal wire in a circuit is damaged. The resistivity of the metal is unchanged, but the cross-sectional area of the wire is reduced over a length of 3 millimeters. Current is 0.650. Ratio in region Y and region X. What is the length? What is the So this ratio we have discussed many times before also. I is the same, so we can cancel out I. Now it is 0.69 and we are talking about X and Y. So we have to be careful that it is Vy upon Vx. So it should be dx upon dy. So the X is D and it is 0.69 D. Now, this is the ratio step.
It is coming as 2.1.
The main part of the wire with cross section X has a resistivity per unit length of this much. Find the for the damaged length of the wire, calculate the resistance per unit length. This is resistance per unit length, R upon, it means R upon L. So let's write down the formula. So I'm getting this ratio R upon L is equal to rho upon A, as the material is the same.
The row will be the same.
Yes. The damaged part is Y.
That was 3 millimeters.
But we already, they want to resist, they want directly ratio, na? So What is R up? Acha, we have been given this value. 1.7. Chale, ab you have to rearrange and get this value.
So the length we'll take as 3 millimeters in the below equation.
No, we need the whole value. We need a complete bracket of R upon L.
It is coming as 0.024. 0.0246. So like almost 0.025.
Okay. I just want to double check that it's A2 upon Y upon X. So it's 0.69D. The power dissipated. So we need resistance somehow. We should find the resistance. So how we can find the resistance? We have R upon L.
We'll need to put a value for L and then do it.
Yes. So we can put the value of this and multiply it with the value to get the value of R. Can you double check this 1.710 power minus 2 upon 0.69? I actually forgot to write it down.
It is 0.0246.
0.0246.
Yes.
So R upon length.
Can you give me 2 minutes? It's time for namaz here.
I also have to say namaz. Just wait for 2 minutes. Just we are having azan in our area within 5 minutes. So you can go and say the namaz, and once you come back, let me know.
No, I can do it after 5 minutes. It's fine.
Then it's fine. Then help me out. R upon L is equal to 0.0246.
No, so, but what will we put as the value for L?
Hmm?
As L.
Length we have now. We have the damage part length is 3 millimeter.
Okay, so we'll put 3 to 10 power minus 3.
Uh,
It is coming as 7.38 into 10 power minus 5.
7 point
38 into 10 power minus 5.
we have the value for current 0.50 ampere. How much answer is now coming?
It is coming as 1.845 into 10 power minus 5. 1.85 into 10 power minus 5.
Ali, can you hear me?
Yes, I can hear you. It is 1.85 to 10 power minus 5. Can you hear me now?
Somehow I cannot hear you. If you can hear me, you can update me on the chat somehow. I'm unable to hear you. अच्छा ठीक है. I think
Can you
then the diameter of the damaged length of the wire is further decreased. Assume that the current in the wire remains constant. State and explain qualitatively the change, if any, to the power dissipated in the damaged length of the wire. You can speak on the mic. I think I can hear you now. Resistance increases.
can you hear me now?
I can hear you.
So I think if there's a like the diameter increases, the area increases, so they are inversely proportional, the resistance and the area. So resistance will decrease.
Ah, area is decreasing now.
Area decreasing, resistance will increase.
So R is inversely proportional to area. Area decreases, resistance increases.
Power dissipated would also increase.
Because power is equal to I square R. A filament lamp is rated at 30 watt, 120 volt. A PD of 120 volt is applied across the lamp. For the filament wire of the lamp, calculate the current.
So we will use P is equal VI and 30 over 120.
Yes.
It comes as 0.25 ampere.
Sorry, 0.
25.
The number of electrons passing a point in 3 hours.
So is it I is equal to Q over T we can also use?
Yes, and then Q
Convert
is
into
by
seconds.
any. N means number of electrons. Here it doesn't mean number density.
It is coming as 1.69 into 10 power 22.
So that the resistance of the filament wire is 480.
So power is equal to V squared over R.
Huh. You can try that, or R is equal to V upon I. We can also try.
It is coming as 480 by this.
480. How much the voltage? 120? Oh, sorry.
120.
I made a mistake. It's the filament wire has an uncoiled length of 580 and made of metal. The metal has resistivity this. So let's see namaz. I think just have a 3-4 minute gap and we can start after namaz. Revision. I shared a revision handout. Did you remember that?
There's like 64 page, there was PDF.
There was a theory and there was formulas, everything, one document.
Yes, I remember.
So that would be ideal to use because that will be a one quick way to revise everything. So we are keeping up to here and we will inshallah continue in our next class. Allah Hafiz.
Allah Hafiz.
देखिए इसमें एक करेक्शन है, और ये जो करेक्शन है इसको देख लीजिएगा। करेक्शन ये है कि यहाँ d2/d1 का स्क्वायर है, और उसकी वजह से हमारा एक आंसर गलत आ रहा था 0.036, वो अब मैंने करेक्ट किया। इसको फिर आप चेंज करके आर की वैल्यू निकाल लें, और जो आर की वैल्यू आप निकालेंगे उसको रख के फिर पावर निकलेगी। तो ये करेक्शन है, इसको करेक्शन को फॉलो कर लें।